So, anybody have any questions about anything? There were several really good questions during office hours. Anybody have any questions? Everything going good out there? You guys doing all right? Okay, all right. I'll give you guys a minute to come in. A few more people joined. Let me know if you have any questions. Let me know if you have any questions. Oh, okay.
I was wondering actually if you could go over in section 4.7, number 4, kind of how to do that, or maybe something similar to it.
What page is that?
I think it's 555.
Got it. Okay. Oh yeah, I love this question. All right. Okay, so let me show this. There's some definite wrong answers for sure, but this is sort of, there's no real way. In fact, so this question number 4 says how far it's actually traveled. Not 150 something feet, but how far this path is. It's obviously more than 150 feet, right? So there are some two simplistic ways that make the answer really far off. Somebody used, all right, let me see. I don't want to give too much away, but there's a really, really good way to do this. Somebody used Pythagorean Theorem somehow, right? Which is the way I would do it if I didn't know advanced calculus, but I do. So hey, so I can find the exact distance. Thank you very much. But that doesn't mean shit. Who cares, Jeff? That's just, I know some more things. Who cares, right? So this is more just being creative. Can you figure out how long this is? Somebody else used conversions, which I really liked. They could measure in inches and do some conversions. That's, I mean, so there's several different ways to do number 4. As long as your attempt is honest and it makes some kind of sense. If you get less than 150, that's bad. If you get like 1,000 feet, holy shit, right? So there's obvious wrong answers. I don't know. So that's as much as I can give you. So this is just like they say, be creative, be, what do they say here? Ingenuity. So be ingenious. That's all it wants you to do, is be ingenious. Just do it.
Okay, that makes sense. I was going to try the Pythagorean theorem at first too, but I just wasn't sure if we were supposed to use the more recent formula you showed us on the 10th. But I'll try that first.
What was that one? The distance formula?
No, not the distance one. I was going to try that too. On the 10th, it was, no, not that. I'm sorry. I'll have to get to you. I'm sorry. I don't want to flip through the pages too much here. Thank you.
You're fine. Yeah. So distance formula basically is what they did, but it's based on Pythagorean theorem. So you can do that too. I love it. All right, guys. Any other questions on anything else? The thing I love about number 4, and I know number 4 is the kind of question that a lot of students hate, but number 4 is kind of like, all right, you've learned some shit. You've got some more stuff in your toolbox, right? Which I don't love that analogy, but it's fine. The more math you learn, it's sort of like learning how a screwdriver works. And now you're able to do more shit around the house. And then you learn how a wrench works. And then you're like, I can do more shit around that. So every time you learn a new mathematical process, you can do more stuff. So this is kind of saying, all right, you know enough math now to try a few things out on this. You can't get the exact answer, but you know enough math to approximate it. All right, that's enough. Anything else, guys? All right. Nothing. Okay. I think we left off. Oops. Oh, I see. Okay. Yeah. I understand. So let me see. I don't think we've done that yet, have we? Did we do that already? We didn't do quadratic formula yet, I don't believe. Or am I insane? Or, those two can be equally true. Let me see. So we did this a while back. So the last thing we did, we were looking at factoring, and we finished. Let me see if I can get back. Oh yeah, we were doing the trees thing. Remember this? The yield for the apple trees. So that's the last thing we did. Okay. And I don't know if you guys remember. Let's do a fresh problem. Oh, look at all this. Oh yeah, white space. Kick ass. I'm gonna use the shit out of this. All right, here we go. Do. So let's do a couple of things here. So if I give you this guy, can you guys please factor? Let's see, this is a nice little review. Please factor this. Bless you. So just in case you're having any trouble out there, we know that x squared is x times x. So that would be the first step in that distribution. That gets us x squared. So the whole question becomes, what numbers go here so I get 30 at the end and I get negative 11 in the middle? And of course, what am I asking myself? Cool, somebody's got the answer. What am I asking myself? I need two numbers that do what? Jeff. Oh, Jeebus. You have a little break and you forget your language. I love it. There's two numbers that do what? Oh, I get some chats. I love it. I can't do all this technology. Yeah, I know that's the answer. That's fantastic. Now answer what I'm asking. You need two numbers that do what?
Add to 11.
Add to be
negative 11.
Negative 11.
Multiply 30.
Multiply to be positive 30. I like it. So what does the fact that they multiply to be a positive number mean? Can they be different signs?
No.
No, I like it. All right, so there's all these clues, which is really why I love this. It's kind of like a forensics thing. You have all these little clues. Okay, it multiplies to be positive. Can't be different signs. They have to be the same sign. Adds to be negative 11. Okay, they both have to be negative. And this isn't too bad. I've already had a few people tell me the answer. So eventually you get negative 5 and negative 6. That makes negative 11, and it makes 30 when you multiply them. Now, can somebody go further? Can somebody tell me what the zeros? Holy Nikes. All right, Penn. You've had a lot of time off. Well, let's work. Zeros. I like to spell like heroes. Zeros. What are the zeros of this bad boy?
5 and 6.
5 and 6. It's just you can tell exactly what values. What does zeros mean? What x values make the output 0? That's what zeros means. It's kind of nice. They're also called roots. I've called them that before. And they're also more formally known as x-intercepts. So all these words mean the same thing. Kick ass. Now, can somebody go even further with this and tell me where the vertex is based on what we've done so far? So it looks like this so far. You see that? Those are the zeros. Is it going to open up or down?
Down.
No.
Up.
Yeah, this is positive, so it's going to open up. It's going to look like this. It's going to be happy, right? Because it's positive. I'm happy. Shut up. But can somebody tell me what the x value of the vertex must be? Because if I have a parabola and it goes through those two intercepts, where's the vertex going to be? Right in the
5.5.
Right in the 5.5. That's right. Right in the middle. So what's right in the middle of 5 and 6? 5.5. So the vertex is 5.5 something. Now let me push this even further. Is everybody with me so far? This is everything we've done so far with quadratic stuff. We factored it. We talked about zeros. And the very last thing we did with the trees was we found where the vertex was. It's always going to be the x piece of the vertex will always be right in the middle of the intercepts. Why does that make sense? Because a parabola is symmetric. Boogie, 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 right? So it's going to be right in the middle of the intercepts. That's where the mirror is going to be, right in the mirror, in the middle. All right. So that's what we've done. And everything we've done is old shit. Here's the one little new thing that isn't really new. Can somebody figure out what the y piece is? Where the hell is the vertex actually? Right. I know the x piece is right in between the two intercepts. I know that. How do I get the y piece? How do I always get the output if I know the input? What's the word input if you turn it around? Tupney. No, turn around like put in. So don't I just take 5.5? I really want you guys with me on this. I just take 5.5 and freaking plug it in. Isn't that how I get the output? Isn't that how I always do it? So stay with me. There are multiple layers here. If I can figure out what the x-intercepts are, the vertex will be right in the middle, the x piece. And then how do I figure out the y piece? How do I figure out actually how high up or how low down I go from there? I plug that in, just like always. If I wanted to output something, I plug it in. So look what I'm going to do. I'm going to plug in 5.5. I'm going to plug it into the factored form because I can kind of do that in my head. Now, if you want to, you can just plug it into your calculator, of course, but I get 0.5 times negative 0.5, which is negative 0.25. Isn't that half times a half a quarter? Now, again, you can do all that shit in your calculator. That's fine. You can do it all in the calculator. I just want to show off my one skill in life, which is math. Now, stay with me now. Stay with me. So everybody got all that. That's a lot. We did a lot of shit with this thing just now. Factoring is a little bit old news by now. Zeros, a little bit newer news, but we get that. Vertex being in the middle of the zeros, a little bit newer. Pen, I swear to God. Pen, all right, I'm just going to get past it somehow. So that's a little bit newer news. The vertex being in the middle of the two intercepts. And then the brand new news is if I want to figure out the y piece, I just plug it in. Well, that's actually not even new news. How do you get the output? You put the input in. Ooh. All right, so my claim is the vertex is 5.5, negative 0.25. So let's check that out. All right, so everybody got all this chicken scratch somehow copied down for yourselves. I'm going to close this, and we're going to do something nifty. All right, here we go. I'm going to close it down. All right, here it goes. Bye, stuff. Now, let me show you this. Hold on. All right, let me mute this tab. Okay, let me bring this over here. What am I? I'm a superhero. I got to say everything I'm doing. All right, here we go. So let me put, I don't know if I've shown you this before, this Desmos. I think I have. Let me put this in here. Look at that. So I put the function in, right? Put the function in. Oh yeah. I was like, why is nothing working? Doesn't that look, so there's my 5, and there's my 6, and there's my vertex at 5.5, negative 0.25. Look at that shit. Maybe. Now, so that pretty much catches us up to where we left off. I added one new thing. I added how to get the whole point, not just the x piece, but the whole point. Now let me mess this up a bit. Let me see if I can mess this up like a lot. Oh shit, I messed it up too much. Too much, Jeff. All right, let me just make something up here. There we go. All right, now look. All right, look at that, disgusting. I just made this up. Let's see what the intercepts are. Jeff, you can do it. There it is. 5.309. Do you think you can get that by hand? With what you know? Some of you guys might know enough, but with what we officially know in the class, I am never going to freaking, are you kidding me? I'm never going to get that. And look at the vertex. Vertex is nice, actually. Dadgummit. I want the vertex to be gross. There. Now it's gross. All right. There's no way in hell I'm going to get this shit, right? So we have, I really want you guys with me on this. So if the intercepts are nice, I can find the vertex and all that. I could do it by hand with what we know so far. The minute the intercepts are gross, or what if I go back to what I had a minute ago? What are the x-intercepts of this graph? Here's the x-axis here, right? What are the x-intercepts? Does it ever hit the x-axis?
No.
No, it starts here and it goes up from there. It never hits the x-intercept, the x-axis. But is there still a vertex? Yes. All right, then stay with me. Again, all I'm doing is this. What we know officially so far, I can find the vertex if it's factorable and the intercepts are nice. You with me? How many quadratic formulas out there are factorable having nice x-intercepts? Not many. If they're out in the wild, more than you might think, but still not a lot. Not enough. So that's the motivation to figure out an algebraic way to do this. What we're doing right now is we're doing this visually, graphically, right? We need an algebraic way to do this. Okay, so let me come back. All right, just trying to lay the groundwork of why we're about to do what we're about to do. Now, I know a lot of you guys probably know this equation already. Let me throw this up here. Oops, where am I? Dadgummit. Here I am. Yeah, okay, I like it. So let me throw this bad boy up here. How many of you guys have seen this before? Wow. So let's try it with something we already frickin' know. The equation we just did. What did we get for the x-intercepts? We got, get in there. We got 5 and 6, correct? You with me? That's what we just did. Can somebody tell me, is this in this form? Well, let me see. Let me put the equal 0 in. There you go. Now it is. Is that in that form? Yes. Can somebody tell me what A is for this guy? What's A?
1?
1, I love it. There's a 1 out here. There's an understood 1 there, right? What's B?
-11.
-11, kick ass. And what's C?
30.
30. All right. Not hard, right? You just got to identify the coefficients. Identify the coefficients. Take a minute, plug these into here. And I'll wait. Try to see what you get. We already know what you should get. We already know you should get 5 and 6. So if this equation can't get those things, screw this equation. Now, if you don't get those things, don't screw the equation yet. You might have just made a mistake. If I don't get those things, then we can throw that equation out and we can leave. So everybody understand what's happening? We got this equation. Now what sucks is I really can't show you. Well, let's see. No, I really can't show you where this equation comes from. That kind of sucks. Makes me sad. So let me try to catch up to you guys.
Wait, did you want to show us like the physical proof, or did you want to show us like where the equation came from?
That's one question, and the answer would be yes.
Oh, okay.
Yeah, because the proof would be showing you where it comes from. I could, and I was considering this. Well, we'll talk in a minute what I might try to do, because this is
I was
built
just curious.
off, yeah, this is built off of something called completing the square. And if you don't know how to complete the square, you can't directly prove this easily. Is everybody with me so far? It's just plugging values in here, right? Now you got to actually do it though. And you can actually do all of this without a calculator. So I get 11, give or take, the square root. 11 squared is 121. 4 times 30 is 120. Do you see how nice that is? 11, give or take, the square root of 1. Well, that kicks so much ass. So that's 11 plus 1 divided by 2, or 11 minus 1 divided by 2. So it's 12 divided by 2, it's 6, or it's 10 divided by 2, 5. There you go, same answers. So the equation does work, too bad. We can't throw it out. Let me see how much I can. Now, all right, let me just say this. Let me ask you guys something. All right. Let me play around with this a little bit. I'm about to do something that you never have to do. If you don't understand what I'm about to say, it's okay. But I do want to go a little bit further with this equation. Is everybody with me on this? Any questions on any of this here? Okay, I'm going to erase this. Here he goes. Bosh stuff. Bang. Now. Oh shit, I didn't want to do that. Dadgummit. Get back here. There we go. Okay. Thank you. Can I divide by A? Of course I can, right? I can divide everything by A. Is that okay? Is that okay? You're like, dude, you're the math guy. Just do it. All right. That didn't make it any prettier, right? But isn't there a 1 out front now? So we're not going to do what I'm about to say, but I want you guys to think in that direction. If I wanted to factor this, which is how I could then find these, wouldn't this be x and x? And then what do I need? I need two numbers that do what? Oh, shit. Here's where you got to really go on the ride for me. What would these two numbers have to do? You could do it. They have to multiply to be what? You could do it. It's gross. You can't tell me a number, but what's in the place where it's got to multiply to be it? So when we did this, let me make sure everybody's with me. Two numbers had to multiply by 30, add to be negative 11. Bam. So what do the two numbers here have to do? They have to multiply to be, you could do it.
C.
Divided by, oh.
They have to multiply to be C over A. And they have to add to be, you can do it, B over A. Now, guess what happens? And this is what I'm not going to make you sit through. And you got to be a little, well, there's a couple of layers here. But basically, if you multiply these two, you do get C over A. And if you add these two, you'll get negative B over A, and that's because of something. That's probably the closest I could get without having to take a couple classes to teach you the thing called completing the square. All right. All right. So let's forget about what I just said, if you want to. If you're curious and you want to try it out, go ahead and try it out. Go ahead and multiply these guys together and then add these guys together and see what you get. Or don't. It's okay either way. All right. Now, let me write this in a little bit different way. Can somebody tell me real quick, in this expression, what is being divided by 2a? I know that might be a weird question. Go ahead.
The whole top equation there?
Good. So what pieces? Negative b is being divided by 2a, right?
Yeah.
The
As
square root
well
of b.
as b squared. And
Sorry?
as well as, oh, you already wrote that down.
Yeah, I got you. I can't break it up any further because this whole thing's under a square root. But here's my point. Stay with me. Stay with me. This is where I need you to come back fully come back. Right? If you were kind of tuning out a second ago, come back. Isn't this, oh, you know what I should have done? Let me do this. Sorry. Let me bring this back before I do what I'm about to do. Remember what we just had down here with x squared minus 11x plus 30. We had 11 plus or minus the square root of 121 minus 120. Remember this? We just had this. You guys remember that? Wasn't that fun times? Now watch. Could I write this as 11 divided by 2, give or take 1 divided by 2, right? That's what this became, right? 1. You guys with me? What is 11 divided by 2?
The vertex.
Yeah, 5.5. Now, I want, come on, stay with me. Whatever this is, whatever this number is, I'm adding something to it and I'm subtracting that exame. That exact same thing. Wow. Sorry, I made a new word. Exame. I'm adding this to it and I'm subtracting the exact same thing from it. So wouldn't negative b over 2a be in the middle of this and this? You guys with me? Because negative b over 2a is what I am adding this to and subtracting this from. So whatever negative b over 2a is, it's the number that's right in the middle of the two x-intercepts. So wouldn't this be the freaking x piece of the vertex? Isn't that the whole thing? If I can find the intercepts Then I can find the number in the middle. Well, the beautiful thing about the quadratic formula, which is what this thing is I can figure out exactly what the number is in the middle. I can just do this piece. What am I talking about? I don't know. So for example, if I had this equation, if I had this function, oh, let's see, let's make it a little more funky. Sure, I like it. How would I find the vertex? All right, what I would do is I would say, oh, I know from the quadratic formula that negative b over 2a is the number that's in the middle. So that is the x piece of the vertex. That is the shortcut. It is a shortcut to find the vertex. So can somebody tell me, for this function I just wrote down, what is b? What is b?
3.
3. I got you. Somebody's motioning to me. I love it. I thought she was telling me to steal third. And what's a? What's a?
2.
2. So the vertex will be at negative 3/4. Right? The x piece. How would I find the y piece now? How would I find the output? How would I find the whole point of the vertex? What would I do?
Plug it in.
Yeah, what is this? We just figured out x is this. So all I'm asking is how to find the y. How do I find the output? Well, you plug that thing in. I really don't want to do that by hand. I'm going to try anyway. Screw you, Jeff. Ace plus, so minus 9/4. Negative 9/4 minus 5 is negative 29/4, which is about negative 7.25. Is anybody doing that for me? Let's see how far off Jeff was. You guys even know how to do that? Plug in negative 3/4. So you just plug in negative 0.75. So you do 2 times negative 0.75 squared. Shit, Jeff. Put the parentheses in the right place. Plus 3 times negative 0.75. Minus 5. Oh, I was off. Oh, well, I'm okay with that. So negative 6.125. What did I do wrong? Did I forget to? Oh, screw it, Jeff. It's all right. It's okay, dude. I have no idea if you guys are with me at all. Are you guys with me at all? I really want you to understand, this is beautiful. This takes the whole idea of what we did with this guy. Remember this guy? This guy over here? This guy way over here? This guy? We found the intercepts, and then we found the vertex because it's right in the middle of the intercepts. This is now a shortcut. It goes, oh, shit. The intercepts are what the quadratic formula gives me, and this is the thing that's in the middle. So this is the shortcut. This is a beautiful shortcut to finding the x piece of the vertex. So how do I find the y piece? I just plug that in. Is anyone trying to do that in the calculator having trouble? Can you guys put negative 0.75 in? And what did I get? I got negative 6.125. All right. Okay, and the amazing thing is that this works even if the parabola does something like this, where it has no x-intercepts. It will still find the vertex. Because, just to blow your mind a little bit, this graph, this function does have x-intercepts. It does. They're just not real, which sucks. It's a stupid word. They're what's called complex numbers, right? You guys heard of imaginary numbers? And I don't mean stuff like 11 million or something. I mean, All right. If you haven't heard of complex or imaginary numbers, you don't have to suddenly know them now. Don't freak out. All right. So can you boil down everything you just said, Jeff, into a quick little summation? Yes, I can. In fact, the book does it for us. I'm going to clear all these drawings away. Here they go. I'm going to clear them all away. Here they go. Bye. So here is the shortcut. Where are you? It takes them all to get there. There it is. Look at that. Right there. For a quadratic function, blah, the x-coordinate of the vertex can be found using this. Once you know the x-coordinate, you can find the y-coordinate by plugging the shit in. I'm paraphrasing. It actually doesn't say that. I want to write a math book where it says that. Plug that shit in. All right. Oh, yeah. So do this. Yeah. Let me just give you the ugliest thing ever and sit back and wait. You got to use your old calculator. Trust me. Oh, my God. So let me put this up here. What I want you to do is figure out the full vertex. And the way you get the x piece, holy crap, Jeff. The way you get the x piece is this little negative b over 2a. Why is this so important? What are the three most important points on a quadratic graph? The intercepts, well, let's say 4 because I've got the y-intercept, and the vertex. And very often the vertex is the most important point. Remember when we said if it was profit function, I want to be here, please. That means most profit, right? That's all that matters, Johnson, is profit. Sorry, I'm not a businessman. I'm nowhere near a businessman. I never want to be a businessman. But, you know, some of them are okay. Some of them aren't evil shits. So in here, I know the numbers are gross. Who cares? You got calculators, right? So this is A. This is B. This is C. And C, I really don't care about it. So in your calculator, you're going to put negative B divided by twice A. I don't know. Does that come out gross? I have no idea. Jeff? Does anyone want to tell me what they got? Anybody? Anybody? Has anybody gotten something yet?
I got negative 245.89.
Should be positive. See how there's two negatives? So to be honest, I didn't even put negative in my, I just realized these are going to kill each other. So I didn't put any negatives into my calculator. I kind of kill them in the first place if they're going to die. Whoa. That's not what I got either. So there could be, very likely could be problems plugging this in the calculator. You need to put parentheses around the bottom if you do 2 times. It's got to know this whole thing is on the bottom. Let me see if somebody's got the right answer. Not yet.
Is it 0.0128?
No. All right, let me show you on my calculator. Let me see. Let me bring him up here. Okay, this is gonna be interesting. All right. No, I guess I can't do that. Shoot. All right, I'm gonna stop sharing this and share my calculator, which unfortunately is gonna kill. Oh, well, too bad. Look at all this weird stuff. Whoa. All right. So 0.71. Yeah, Jeff. Divided by parentheses 2 times 0.00. What was it? 46? Is that right?
146.
Sorry?
146.
146.
0.00146.
Thank you. So that's the right answer right there. Do you guys see how the calculator is kind of dumb? It is. It really is. It's dumb as shit. It's just a thing. We're the humans. We go, okay, dumb calculator. Let me put parentheses so you know that this is on the bottom. Thank you, human. Right? Does that make sense? Are you guys all right? Is anybody okay? Okay. All right. So let's come back. Let's now that we got in the technical. Sorry, go ahead.
Oh, I just said I'm okay.
Oh, good. All right. Now that we got the technical part aside, let's come back to the physical problem. So in this problem, let me come up here. Shit and a half. Did they tell me what the hell? Hold on, guys. I think this starts way back here. Jeebus. I'm trying to remember what they're. Here we go. Here's the equation we just used, right? So they tell me the output is the height above the ground, and the input is the horizontal feet traveled. All right, so we got to know that. So what did we just figure out? We just figured out. Come here. We just figured out the x value, right? Which was 245.89. Just rounding a bit. And I think it was feet. So this is the horizontal distance traveled. So again, if I graph this bad boy, it's going to look like wee-ha. So what we just figured out is this is how far it went. No, I didn't. This is how far it goes until it gets to the highest point. There you go, Jeff. I got to remember what I'm doing. So we found the vertex, which is right there. So we just figured out the horizontal distance until it hits its highest point up in the air. Now, how high up in the air is it at that point? How do we figure that out?
Plug it in.
Plug it in, yeah. So now I just do f of 245.89. I want to show you something kind of neat. All right, there's not much here. Copy what you need down. I want to bring the calculator back so I can show you guys something kick-ass cool. So kick-ass cool. We hype this up so much that there's no way it can live up to it. This is going to blow your mind. Okay, I'm going to clear this away. And I'm going to show you my calculator. Bam. Calculator, where are you? There you are. Where'd you guys go? I lost you guys. There you are. So let me show you my calculator again. Stay with me now. Stay with me. Here we go. Calculator. Can you still see my calculator? Oh, shit. You can't, can you?
I can see it.
Can everybody see it?
Yes.
That's there.
Okay. All right. Thank you. Can you see I just typed in 8?
No.
All right. That's the problem. Okay. I don't know what just happened. It has decided to stop. There you can see now the 8, right?
Yes.
All right. So it just doesn't want to let me see. All right. Here we go. Thank God. Excuse me, everybody. So stay with me. If you're playing along with me, and well, all right, this only works if you have the TI calculator. That kind of sucks. So let me do this the whole way out. So And then I'll show you, in case you have the TI calculator, I'll show you something kind of cool. But here we go. Let me try to plug this in the equation. Negative 0.00146 times 245. We'll estimate a little bit. 89 squared. There we go. So there's x squared plus 0.718 times 245.89. There's 0.718 times x plus 2.5. Bam. So now it's almost 91 feet up in the air. You guys with me? So that's just plugging that into the equation. Now, real quick, if you have a TI calculator and you do this, and you get that answer. You ready? You could do this. Negative 0.00146 times second answer. That guy has the last answer on the screen, squared, plus 0.718 times answer, plus 2.5. Same answer. Yay. Yay. All right. So what's that?
You hit the up button to get
Say again? Oh, yeah. Second negative, because that's where the answer key is. And that key. But you know what I mean? That always has the last number that showed up in the screen. So now what will it have? It will have 90.77, blah, blah, blah. So that's the coolest little memory button in the TI calculator. It has the last number that showed up on the screen.
Pretty cool.
So if I do times 3, see how it automatically assumes, oh, you mean to multiply the last thing you got by 3. And now it's going to have 272.3, blah, 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 blah. So then if I had to do the square root of that, then I get the, okay, that's enough, Jeff. All right, all right. So that is kind of the coolest little quick memory location in the TI calculator. All right, so let me come back. Where were we? Get over there. Oh boy. So now we got the output was 90.7 or something, right? I can't remember now. And of course that would be the height it got. So that's the highest point that it got to, and the X piece was along the ground. When did it get to its highest point? Okay, maybe. Oh my goodness. All right. Okay, so this is better. At least it's not snow cones. And now it's bath beads. Can somebody help me out? What the hell is bath beads? Does anyone know what bath beads are?
They're oil-filled beads that you drop into the tub and they dissolve.
They're like a more gentle version of a bath bomb.
Yeah, there were a lot of women used them in like the late 90s. They were really popular then.
Oh, I see. All right. This is amazing. Not only do you know what they are, you know some history. I love it. I like the bath bombs. They look like little planets. And you
So
just
it's
throw
not
them.
soap?
Huh?
So it's not soap?
Sounds like it's oil. Is that what you said?
Why do you
Yeah,
want,
they were like filled with like oil.
why would
Okay.
you want to put oil in your bath?
For
Dude.
moisture.
It's for your skin, for moisturization.
I'm
Dude.
confused.
So many things happen in the past. Anyway, that's enough. Let's see. All as a guy, I just want to get clean. That's all I want. But there's other things you could do. Let's see. So the price function and the revenue function and the profit function, blah, 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 blah. Okay, stay with me. So the most important thing here is that's the profit function right there. So now we have something we can kind of hold on to a little bit better. How many freaking things of bath beads do I have to sell in order to make the most profit? So that's eventually where they're going to go to with this problem. Blah, 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 blah. Eventually they're going to get there with that question. So we're going to do that question right off the bat. If this is my business and I know the profit function, don't I want to use it to figure out how many bath bead things, like boxes of bath beads, bath bead boxes, how many bath bead boxes do I have to sell to make the most profit? That is what I want to know, right? Can you guys take a minute and figure out this guy's vertex? All right, this is the profit function. I don't care about this and this. I don't care about the profit function. Profit function. So figure out the vertex of this. We're not going to answer their dumb question. We're going to answer the smart question. When the night has come, the land was dark. The moon is the only light we'll see. Bath beads. Bath beads. Da -na 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 -na. Some oily bath water sounds fantastic. All right, here we go. So B is 18.5. A is negative 0.025. What do you think, Jeff? 0.05, 185, 0.5, 370?
Yeah.
Do you guys get that? 370? What does that mean?
Yes.
What does it mean?
Is it the X?
True, it's the X, but what does it mean for my business?
370 boxes need to be.
Yeah. Yeah, 370. We're going to call them boxes of bath beads because I'm pretty sure, I don't know if it's each individual bead. I'm pretty sure we sell boxes of bath beads, right? I mean, like $40 per bead. Damn, that's got to be some magic freaking oil. Shit. So in order to hit our maximum profit, I need to buy and sell, right? 370 boxes of bath beads. What will my profit be? How do I figure out what my profit is?
Let's plug it in now.
Plug it in. I love it. So my profit. So just finish out the vertex. So far we got the vertex is 370 comma something. Negative 0.025 times 370 squared. Come on, math boy. You going to do this one in your head? Maybe. All right, Jeff. Really? You're going to try this in your head? Yes, I am. Let's see. Oh, shit. About 9. About 9. I don't know what that is. 3,400. It's like 30. I don't know which way is wrong. I don't know. It's like 3,300 or something. I don't know. I'm probably off by a few hundred. I'm probably way off. Screw me. I don't know what I'm talking about. Let's see. What did you forget to do, Jeff? Oh, okay. I'm not too far off. Anybody get that answer?
$3,097.50.
Yeah, don't forget those 50 cents, man. Holy shit, Jeff. How many decimals are you going to have in that? 3,097.50. So that's the other piece of my Vertex. Yeah. Not bad. That's a decent little profit for our little bath bead business. Beautiful boxes of bath beads. Boy, that's the name of our company. You have no say in it. Do you guys see how that's remarkably useful? A shortcut to figure out what the vertex is. Why is that good? Because the vertex is very, very, very often the most important part of the graph. So if I have a quick way to find it, that's awesome. And there it is. There's a quick way to find it. So what would happen if we sold 360? What would happen to this?
It would go down.
Yeah, exactly. What would happen if I sold 380?
It would go
would-
down.
It would go down, exactly, because that's the highest point, Jeff. We get it, Jeff. Stop it. All right, I'm sorry. I'll stop. Okay. All right. So let me clear this away. Clear. You didn't clear it, Jeff. I know. There it is. Okay. Blah, blah, blah. So they eventually catch up to us with this problem. Find the exact maximum profit. That's what we just did. Oh, now let me see. So what should they charge for each jar? Oh, it's a jar of bath beads. Now you tell me. That doesn't go with my jar of bath beads. That doesn't work. Bottle of bath beads. That works. Oh, I went too far, didn't I? So how would I figure out how much they should sell each jar for? Remember, we got X was 370, so I got to sell 370 jars. Which piece of this tells me how much I should sell the jars for? Which formula gives me the price of the jars?
Is it y equals mx plus b? Or the
I see.
Okay.
Well, they give me the formula right here, right? This is the price right here. So if I'm going to sell 370, so if I expect to sell 370, I'm going to put 370 into this equation and figure out what price I should sell them at. So here's the thing. Now, again, remember, the formula, the actual formula in real life will be a little more complicated because there's a few more variables. But if you only use this, you will get decently close to the right place. If I sell my jars for less money, more will buy them, but I'm getting less revenue total. So somewhere there's a sweet spot of a price point. So 370 jars seems to be the sweet spot. So I could just plug 370 in here to figure out what that price is. 22 minus, let's see. So that is about 11. Is that right?
75.
What is it?
1275.
1275? Okay, that's close enough for me. What do I keep doing wrong? This is close enough, Jeff. Anyway, all right. So the whole point of this is something that a few of you guys have some trouble with. You've got to keep track of what each little variable means. X means number of jars throughout the whole thing. Little p is the price function. That's how much you're going to sell them for. Big R is the revenue function, and big P is the profit function. You've got to know which is which. So when they ask you a question, you use the right formula. That's it. Okay, so let me see. I think the homework should look very much like that. Oh, this is interesting. Yeah, so here you can use a calculator, make a table of values to plot that, so you get a nice little parabola. You could even use the Desmos thing if you want to and take a snapshot of it, because it says you can use a spreadsheet or something. And then again, have you use the formula to figure out the vertex. They give you nothing but golf shots and freaking balls. Here we go. What's this one? Again, it's the World Series. All right. Sorry if you don't like sports. It's too damn bad. They got nothing but sports here. Which kind of makes sense. Sports, you're throwing shit. They make parabolas. What you do. Okay. I like it. There's one thing I want to go back to. There's something in an earlier section. Where was it, Jeff? You can do it. Oh, yeah. Okay. Was it here? No. Where was it? Where's the, oh yeah, it was here. Here we go. This problem right here. There was a question. Explain why the shape of the graph on the previous page does not tell you what the flight path looked like. So the correct answer is not, well, it does look like a flight path, because they're telling you it doesn't necessarily represent the actual flight path. Could this represent the football physically moving if I just threw the football straight up above my head?
Wait, with the graph? The graph can.
Yeah, this graph right here, this specific graph right here, could it represent the ball if I threw it straight up over my head? And then I catch it.
Yeah, I mean, just because it's measuring time, not distance.
Good. Beautiful. There it is. There it is. So what would the side view of this look like? A straight up and down line. I mean, whoop-de-doo. But if I do it over time, I throw the ball straight up. 1 second later, isn't it higher up in the air? So this could represent the motion of a ball that's thrown straight up, because like Vu just said, you just said it beautifully. This is per time. This does not mean actual motion in this direction. It's only motion in this direction. Do you guys see that? This picture is a flight path. Why?
Measuring distance.
Now it's distance in both directions. There's no time component here. When was it right there? I have no idea, because they don't tell me anything about time in this problem. So this would actually be what the trajectory looked like from the side, because it's distance and distance, right? This one is distance versus time. So that could have been, I could have thrown it backwards. I could have thrown it straight up. Okay, maybe. Okay. But because we live on Earth and there's gravity, most things we throw up, no matter if I throw it straight up or I throw it at an angle, when I graph it with respect to time, it's going to be parabolic. Let me see if I can push this a little bit. What would make it not quite parabolic? We're on Earth. I throw it in the air. Go ahead, sir.
If it fell on something, it didn't come back down on the ground.
Okay.
Like
Okay.
a roof.
So let's say that I'm on a perfectly flat plane, nothing's around.
You roll it on the ground?
No. I still throw it up in the air. I'm not changing that. I could throw it straight up or I could throw it out. What would make it not parabolic? Say again?
Somebody caught the ball.
Nobody else is around. All right, so here it is. This is a thing about, this is ignoring, no, we are on the Earth where gravity does exist, right? All right, so it's just, there could be a lot of wind, right? Could be a lot of wind, could be whipping up in all directions. Other variables is what I'm talking about. So this is ignoring other variables. You guys semi with me? And I know that was an evil question. There's no way you would have known exactly what the hell I wanted there, but every equation we look at is ignoring certain variables, and some variables barely affect anything. So I can ignore them fine and get a very good idea, but some variables affects things a lot. So the more math you learn, the more you can take into account wind resistance and other things. And what if you throw that in the mountains? Gravity is actually different if you're in the valley, not the valley, not, you know, like gag you with a spoon, but in between high mountains because the mountains pull you with their own gravity and you actually weigh less if you're standing next to a few mountains, believe it or not. So that would change the flight path. They would still be. Anyway, that's way too much, Jeff. Way too. I'm sorry. So this homework in section 410, I believe we were just in. Is that right? Yes, because that's that's factoring. And 410 is all about, quadratic formula, baby. This homework should not be overly evil. It's pretty much exactly like the examples they gave us. Okay, so you just try that stuff out. I have a practice final created. I just have to put it up on the website. It's not fully created yet, so I got to finish putting it together and then I'll put it up on the website. When's our last day of class? I do know, by the way.
Or 7?
The 8th?
Yeah, a week from today. A week from today is the last day of class. You guys with me? A week from today is the last day of class, of all classes. Starting on the 8th is final exams. So your whole schedule is going to possibly change a bit, right? When is our final exam happening? What time? And what day?
The 8th at 9:25 to 11:25.
There you go. So I will have office hours before our class. In fact, I'm going to put together a schedule. It's not going to mean as much for you guys because your finals immediately after that Monday, which is kick ass because that Monday we're going to review for the final. And then Tuesday we have the final. That's so freaking awesome. So I will have office hours before class on that Tuesday. And of course, you're going to have to be on Zoom with your camera active for the final exam. This is not going to be like a normal, like a quiz thing. It's going to be, we're going to do it live. Okay, I like it.
Are we having a quiz this week too? The last quiz?
Yeah, the next quiz is on Thursday, right? It's 4.3 through 4.8. So I'm trying to keep up with grading all the homework. I'm doing pretty good, I think, at the moment. All right, that's all I got for today. That's enough for today. So if you need to hang out for a bit, let me know. Otherwise, you are free to go. All right, guys. I'll see you all later. Oh, yes.
Just a quick thing. Are you teaching any, the next course is, this is the prereq for stats. Are you teaching any stats courses other than just the one that I found?
No, just the one. Yeah.
Okay, just curious.
And once again, Jeff, what time is it? It's the finals at what time? 11?
What was it? 9:25. Yeah. 9:25.
9:25.
It's on the syllabus and it's on the homework sheet. Yeah.
All right. Thank you.
You're welcome.
See you soon. Thank you.
Sure. All right. I'll see you guys.